Usually when we think about the human body, we picture this squishy, wet biological engine.
Right.
Like a really complicated flesh and blood car. You eat food, it burns as fuel, and, deterministic chemical reactions just make your muscles move and your brain think.
Yeah, it is a very reassuring way to view the world, honestly.
It is. It's comforting.
Yeah.
We like to think of ourselves as solid, predictable, classical chemistry.
Exactly. That Newtonian mechanical view of biology tells us that A causes B, which causes C. Everything is neat, contained, and, well, most importantly, it obeys the rules of classical physics.
But then you step into the world of cutting-edge biophysics, and suddenly that mechanical engine looks completely different.
Completely different.
Like, what if beneath all that warm, noisy biology, your body isn't just a chemical engine at all?
Yeah.
What if you sitting there listening to this right now are actually a massively parallel, highly coherent quantum computer?
I mean, it is the absolute definition of a paradigm shift. We are looking at a biological reality that completely shatters the classical textbook.
Right.
We're finding that life isn't just utilizing physics. It's utilizing the deeply weird, invisible quantum layer of physics to function.
Welcome to today's deep dive. We have an incredibly fascinating stack of sources today, mostly centered around this really dense, cutting-edge research report titled Quantum Biological Substrates.
That's a heavy read for sure.
Very heavy. But our mission for this deep dive is to decode how biological entities, meaning you act as actual quantum hardware nodes.
The nodes that are literally rendering reality.
Exactly. Rendering reality using atomic spins, magnetic fields, biophotonics. And look, I promise, we are stripping away the dense postdoc level jargon today. We're getting right down to the underlying mechanisms.
You're going for massive aha moments today.
Yes. But we should probably establish right up front, this isn't science fiction.
No, not at all. And it isn't quantum mysticism either. We aren't just, throwing the word quantum in front of things to sound cool.
Right, like quantum healing or whatever.
Yeah.
Exactly. What we are discussing is backed by hard, granular data spanning multiple scientific disciplines. We're looking at measurable, repeatable quantum mechanics operating inside the warm, wet environment of mammalian biology.
And that warm, wet environment is actually the perfect place to start. Because anyone who follows tech knows that human-built quantum computers are incredibly fragile.
Highly fragile.
Right. Like, to keep their data from scrambling, IBM or Google has to house them in these massive refrigerators and cool them down to, like, near absolute zero.
Yes.
So if my body is hot, noisy, and chaotic, how on earth is it protecting delicate quantum states?
That is the multi-million-dollar question in biophysics. The primary obstacle to quantum cognition has always been rapid thermal decoherence.
Basically, heat and noise just destroying the fragile quantum data.
Exactly. Heat shakes the system apart. So to maintain macroscopic quantum coherence without just melting down, your body requires a highly specialized chassis.
Yeah.
It needs the biological equivalent of a Faraday cage. The report calls it a localized dielectric suppression field.
Wait, dielectric suppression field?
Yeah.
What does that actually mean in plain English? If I'm looking in the mirror, where is this field?
Think of it like a combination of a biological lightning rod and active noise-canceling headphones.
Okay.
It is a physical shielding system made primarily of carbon. Your biological carbon networks, when combined with dense mineralized structures like your bones.
My bones.
Your bones, yes.
Yeah.
And the highly conductive layers of your skin. Together, they create this grounding net. It actively routes high-gain electromagnetic interference around your core processing centers like your brain.
Wow, so it prevents my internal data from instantly desynchronizing.
Right. It catches the static and routes it away.
So my bones and my skin are literally acting as a static shield, deflecting the chaotic static of the universe.
They are, but a static shield isn't enough on its own.
There's more.
There is a dynamic liquid component to this chassis as well. Complementing that static carbon mesh is a liquid hardware switch, and it is flowing through your veins right now.
Okay, my blood.
Your blood. Specifically, we're talking about the oxygen binding to the iron in your hemoglobin.
Let me see if I'm tracking this. Iron is obviously magnetic.
Yes.
So is my blood essentially acting like a liquid hard drive reading magnetic data?
It's acting more like an active magnetic dampener. And it works because iron's magnetic properties change radically based on whether it's holding onto oxygen or not.
Oh, interesting.
Yeah. So when your blood leaves your lungs, it is oxygenated. This oxyhemoglobin is diamagnetic.
Meaning it pushes magnetic fields away.
Correct. The chemical structure at that moment possesses no unpaired electrons, which means it actively repels external magnetic fields.
It's a shield.
Exactly, a shield.
Yeah.
But as that blood travels through your body and drops off that oxygen to your tissues, it becomes deoxyhemoglobin.
Okay.
And that subtle molecular shape change suddenly exposes 4 unpaired electrons per heme group.
And that changes the magnetism.
Almost instantly. The molecule flips to become strongly paramagnetic. It starts attracting magnetic fields.
Okay, let's unpack this.
Yeah.
Because that is wild. So if I just take a deep breath right now, I am manually flipping billions of subatomic magnetic switches.
You absolutely are.
My breath is literally a volume knob tuning my body's magnetic resonance.
That is a phenomenal way to visualize it.
Yeah.
By altering your respiratory rate, whether autonomic, just breathing as you go about your day,
Right.
or like during deep breath work, you are continuously recalibrating the harmonic resonance of your biological page.
Wow.
You're adjusting your sensitivity to external electromagnetic data in real time.
Which completely recontextualizes why breath work, or on the flip side, panicking and hyperventilating
Yeah,
has such a profound effect on our state of mind.
exactly.
It's not just relaxing or tensing your muscles. It's physically altering your magnetic susceptibility to the environment.
It's a hardware level recalibration.
Man. Okay, so we have this beautifully shielded, magnetically tunable chassis.
Yeah.
But if my blood is guarding the hardware, what actually is the hardware?
Right, the processor.
Yeah, what is the CPU inside that shell actually doing the computing?
For that, we have to look at the element phosphorus, specifically the phosphorus-31 isotope.
Okay.
It possesses a nuclear spin of 12. Advanced biophysics frameworks identified this specific nuclear spin as the brain's primary quantum bit, or quartet.
But wait, again, if phosphorus is just floating around in my hot, wet brain, how does its delicate spin survive the heat? We just talked about how fragile quantum states are.
Because the body builds microscopic, highly symmetric vaults to lock them in.
Volts.
Yeah, they're called Posner molecules. They are tiny, naturally occurring clusters of calcium and phosphate.
Okay.
Inside the crystalline geometry of a Posner molecule, the nuclear spins of those phosphorus atoms are perfectly sequestered. The heat and electric fluctuations of the brain they can't reach them.
They're locked in a safe.
Exactly.
But how does data actually get generated and shared if it's locked away in a tiny safe?
The mechanism starts with how your cells burn energy. You've probably heard of ATP, right?
Yeah, the chemical energy currency of the body.
Right. When your body enzymatically cleaves or cuts an ATP molecule to release energy, the separated phosphate ions can become quantum entangled.
Meaning whatever happens to one instantly affects the other.
Precisely. Even if they are physically separated.
Right.
So if these entangled linked phosphates are then scooped up into different Posner molecule vaults, those entire multi-atom clusters inherit that quantum link.
Oh, wow.
Yeah, and they can then physically travel across your brain's synapses into entirely separate neurons.
Still linked.
Still linked. When they finally dissolve, they release a coordinated shower of calcium ions at the exact same time.
So that triggers synchronized firing across physically separated regions of the brain.
It provides a purely quantum mechanical explanation for how your brain binds complex information together instantly.
Okay, wait, I have to push back here.
Go for it.
Because my high school chemistry teacher definitely told me that isotopes of the same element behave exactly the same way in the body. Classical chemistry unequivocally dictates that, right?
It does.
So if my brain's processing is truly based on the invisible spin of an atom's nucleus, what happens if you swap it with something that has a different spin?
You've just hit on the lithium anomaly.
The lithium anomaly.
Yeah, and it is perhaps the most profound experimental validation of this entire framework.
Because lithium isn't just the metal we use in phone batteries. It's also a common clinical drug used to treat extreme mood fluctuations, like bipolar disorder.
Exactly.
But lithium is just a simple element. How could one tiny variation in a basic metal completely alter human consciousness?
It all comes down to quantum spin. Natural lithium has 2 stable isotopes, lithium-6 and lithium-7.
Okay.
Now, classical chemistry insists that these 2 isotopes have identical atomic radii and electron configurations. They should react the exact same way biologically.
Right. Same chemistry.
But they don't. In 1986, researchers fed pregnant rats highly purified diets of either lithium-6 or lithium-7.
And what happened?
The results were staggering. The rats given lithium-7, which has a nuclear spin of 32, exhibited what classical pharmacology expected.
Which is what?
Depressed alertness, sluggishness, suppressed maternal behaviors. It acted as a heavy grounding mechanism.
But what about the lithium-6 rats? The only difference is an invisible number on a chalkboard, right?
The only difference is that lithium-6 has a nuclear spin of 1 instead of 32.
That's it.
That's it. And those rats exhibited severe systemic overclocking.
Overclocking, like a computer processor.
Exactly. Their alertness was categorized in the study as very high. They obsessively built nests, nursed constantly, and groomed their pups excessively.
And difference in spin.
Yes. And we now have the high-resolution electrophysiological data to back this up. Perfusion with lithium-7 depresses the system, decreasing neural synaptic amplitude by 58%.
Wow.
But perfusion with lithium-6 acts as a neural amplifier, physically increasing amplitude by 32%.
That completely breaks the classical textbook, doesn't it?
Yeah.
The mammalian brain can literally feel the difference in the quantum spin of a metal, and it completely alters behavior.
It does.
Does anything else do this?
Magnesium-25 does. It acts as what researchers call a rotary overclocker.
A rotary overclocker?
Yeah. Through a mechanism called nuclear spin catalysis, its specific spin actually accelerates the production of ATP by 2 to 4 times compared to spin-zero isotopes.
Wait, really? The spin physically accelerates the chemical reaction?
Yes, it physically accelerates it.
Okay, so our brains are these hypersensitive overclocked processors tuned to the invisible spin of atoms. But if we are that sensitive, why aren't we constantly overwhelmed by the chaotic, noisy world around us?
That's a great question.
Like, how do we take in data from the environment without immediately crashing?
To process environmental data safely, the biological hardware uses internal sensors called cryptochromes.
Cryptochromes?
Yeah, they're light-sensitive proteins found in everything from plants to migratory birds and even in the human retina.
Okay, and how do they work?
They operate using the radical pair mechanism.
Walk me through that. How does light turn into a quantum signal?
When a blue photon of light hits a cryptochrome in your eye, it triggers an ultra-fast electron transfer. This creates a pair of molecules, radicals, that share entangled electrons.
Okay, I'm with you.
These electrons begin oscillating rapidly between different quantum spin states. The brilliant part is that the final chemical output of this reaction depends entirely on which spin state the electrons are in when they finally recombine.
So if an external magnetic field, even a weak one like the Earth's, passes through you, it nudges those electrons into a specific spin state.
Exactly. And that nudge alters the chemical yield. It translates invisible magnetic waves into concrete chemical signals your nervous system can read.
That is so elegant.
It is, but for a long time, classical models assumed these radical pairs were too tightly bound and too fleeting to be sensitive to a field as weak as the Earth's.
But the report shows they bypass that limitation, right? Using the quantum xeno effect, which, by the way, is one of my absolute favorite concepts in physics.
Oh, it is deeply counterintuitive. The quantum xeno effect states that continuous observation of a quantum system freezes its evolution.
Like the old saying, a watch pot never boils.
Exactly. If you constantly measure a quantum state, it can't decay.
Hold on, though. What is the biological environment actually observing? My cells don't have little eyes. How do they watch a quantum state?
Right. In physics, observation just means interaction or measurement.
Okay.
The highly asymmetric chemical pathways surrounding these radical pairs act as a continuous measurement. The environment is constantly poking at the radical pair, asking, what state are you in? What state are you in?
Oh.
This continuous molecular interrogation effectively freezes the coherent state, artificially extending its life and maintaining acute sensitivity to the Earth's magnetic field.
Here's where it gets really interesting, though. Because if we want to talk about taking in massive amounts of data, we have to talk about the absolute king of sensory processing mentioned in the sources.
The stomatopod.
Yes, the mantis shrimp.
The stomatopod is a marvel of quantum biological engineering. For context, humans use 3 classes of photoreceptors to see color. We mix red, green, and blue.
Right.
The mantis shrimp uses up to 20 functionally distinct classes.
20?
12 of those are dedicated just to high-resolution color. Furthermore, they are the only known animal capable of detecting circularly polarized light.
That is a staggering influx of visual data. How does a shrimp with a brain the size of a pinhead process all that without just, short-circuiting and melting down?
They use a dynamic called prismatic fracture.
Prismatic fracture.
Yes. Instead of trying to integrate and compute all that raw, overwhelming data, Specialized neurons in their optic lobe perform advanced subtractive
I
filtering.
can crack it.
They actively, deliberately erase specific streams of data in real time.
I love this concept so much. It's like a biological prism splitting blinding white light into manageable subchannels, or, having 1,000 browser tabs open at once, which would normally crash your computer.
Right.
But your brain has this ultra-aggressive pop-up blocker that instantly deletes useless tabs before they even load. It's active subtraction.
That pop-up blocker analogy is spot on.
If you're listening to this, imagine your own nervous system doing this when you feel overwhelmed, subconsciously fracturing the data, muting certain frequencies, just to maintain sanity.
Exactly. By processing these channels in parallel and erasing redundancies, the biological system maintains a coherent lock on reality, completely immune to shifting illumination or extreme noise.
Okay, so we have this aggressive pop-up blocker to deal with intense input. But what happens when the entire system is deliberately paused?
Oh.
What dictates the baseline of consciousness itself? That brings us to the anesthetic anomaly, which absolutely blew my mind.
This is where classical pharmacodynamics completely fails to explain reality. We're talking about xenon.
Right, the noble gas.
Yes. Xenon has a completely full shell of electrons. It is chemically inert, and it is utterly incapable of forming standard covalent bonds in the body.
Okay.
Yet it functions as a highly potent general anesthetic.
But if noble gases don't react with anything, how can something that doesn't chemically react put you to sleep? The classical explanation is just that it acts like a microscopic deadweight, right? Just wedging into neuronal receptors and physically blocking them.
That's the old model, yeah. But it ignores the isotopic dependency.
Here we go with isotopes again.
Exactly. The anesthetic potency of xenon isn't about its shape. It's strictly governed by its quantum nuclear spin. Xenon isotopes with a non-zero nuclear spin, like xenon-129, exhibit an anesthetic potency that is 45% lower than spin-zero isotopes.
Wait, let me get this straight. Spin 0 and spin 12 xenon have the exact same physical size and the exact same electron clouds.
Yes.
But just because one isotope has an invisible nuclear spin, it is nearly half as effective at knocking you out.
Yes, because when a spin-zero xenon atom enters the receptor, it just sits there.
Yeah.
It physically obstructs delicate quantum processes, rapidly inducing unconsciousness. It is the deadweight. But when a spin-12 xenon-129 atom enters that exact same pocket, its inherent nuclear magnetic moment comes into play. It creates what the report calls a localized rotational torque.
What does that mean physically? How does torque keep you awake?
Imagine trying to lock a door, but the key you put into the lock is vibrating so violently that the deadbolt can't slide into place.
Oh, wow.
The xenon-129 atom's spin causes it to couple to surrounding electron spins, actively pumping and agitating the quantum electromechanical activity of the neuron.
So it is actively fighting its own anesthetic properties. The vibrating key keeps the brain awake.
Yes.
It's mind-blowing that an isotope's invisible spin literally dictates whether you are awake or unconscious on an operating table. That really highlights how sensitive we are.
Incredibly sensitive.
And this sensitivity leads to how these biological nodes communicate in a noisy environment, right? What the sources call silence carriers.
Yes. Biological nodes don't just communicate through continuous positive signaling. If everyone is shouting in a crowded room, more shouting doesn't help.
Right, it's just noise.
Exactly. In chaotic environments, they coordinate through silence carriers, the structured absence of signals.
Is this like the negative space in a painting?
Yes, very much like that.
Or, to use the crowded room analogy,
Yeah.
if you're at a loud concert and the music suddenly drops out, that silence is more noticeable than a louder sound. We're actually communicating through what we don't do.
You've got it. By coordinating through structured absences, like a pregnant pause in a conversation, biological nodes can synchronize far more effectively. The absence of the signal is the signal.
Wow. Okay, we've covered these incredibly localized quantum events, spins, radical pairs, magnetic breath tuning. But, my toe can instantly communicate with my brain. How are these massive amounts of quantum data physically routed through the body over long distances?
For that, we look to the cellular cytoskeleton. Specifically, structures called microtubules.
Microtubules.
Yes, they are spiral cylindrical protein polymers that give cells their shape, but functionally they act as biophotonic waveguides.
Meaning they're biological fiber optics piping light through the body.
Exactly. Microtubules are saturated with the amino acid tryptophan.
Oh, like in turkey?
Same stuff, yes. A single microtubule can have up to 100,000 tryptophan dipoles aligned in a highly ordered network.
Oh.
These networks exhibit superradiance. Because of their perfect alignment, they synchronize to absorb and emit ultraviolet photons at massively accelerated rates.
Wow.
This allows for ultra-fast, long-distance data routing across the expanse of a neuron.
But the report mentioned they don't just transmit data. They can actually trap it.
Yes, through what's known as subradiant dark states.
Dark states.
Yeah, the specific geometry of the lattice can cause the dipoles to oscillate out of phase. This creates destructive interference.
So the waves cancel each other out.
Exactly. They cancel each other out in a way that prevents the photon from being emitted. It effectively traps the energy packet, the excitant, within the lattice for tens of seconds.
Wait, let's pause on that. Tens of seconds in the quantum realm is practically an eternity.
It is a massive duration.
Right.
And this provides the physical mechanism for a biological optical memory buffer.
A memory buffer.
Think about the physics of holding a thought. This is what that looks like on a quantum level. The microtubule is shielding a superposition of possibilities from thermal noise, trapping a particle of light, until the system finally commits to a decision.
That is incredible.
And once the decision is made, the dark state collapses and releases the energy.
That fundamentally changes how I view my own memory. And, well, what about DNA? We always picture DNA as this static, dusty hard drive of genetic code sitting in the nucleus.
It is far from static. The precise parallel stacking of the base pairs within the double helix transforms DNA into a highly efficient molecular wire.
A wire.
Yes. Biophysicists have measured ground state charge transport migrating down the DNA axis at immense speeds over long distances. So in simple terms, your DNA is a live electrical wire.
That's crazy.
Repair enzymes constantly send electronic pulses down this wire to detect microscopic damage, reading variations in electrical resistance.
It's true chemistry at a distance,
Yeah.
zipping signals down the line to check for mutations. But how does the body control that flow of data?
Through epigenetic clamps. The process of DNA methylation adds a small chemical tag, a methyl group, to the strand.
Okay.
Now, this tag doesn't inherently block electrons, but it acts as a physical clamp. Think of it like pinching a garden hose to stop the flow of water.
Right.
It heavily alters the local flexibility of the DNA strand, physically cutting off the electrical signal to select specific genetic outputs.
Okay. We've been deep in the microscopic weeds here.
Yeah.
Let's zoom out to the macro level, because we don't exist in a vacuum.
Yeah.
How do giant external forces like the sun factor into this quantum hardware?
The sources refer to the sun as a massive heat lamp, broadcasting a great enfolded gradient stack.
That sounds super complex.
It sounds complex, but it just means different wavelengths of light act as specific configuration channels for our biology.
Okay, like what?
Well, red light, which penetrates deeper into tissue, stabilizes and repairs the cellular lattice. Blue light activates and entangles.
So the ambient radiation of our solar system is effectively cooking our biological hardware into its functional shape.
Exactly, cooking it with specific frequencies.
And it's not just light from above, right? The physical earth beneath our feet is part of this engine too.
Yes, through piezoelectricity. Collagen is the most abundant protein matrix in your body. It's in your skin, your tendons, your bones.
Right.
And it is an endogenous piezoelectric engine, meaning under mechanical stress or pressure, it generates massive electrical potentials. Research shows that mineralized collagen can generate a staggering 83 volts under just 75 newtons of compressive force.
Wait, 83 volts inside the human body, just from physical pressure.
Yes, 83 volts. The theory suggests that when biological entities inhabit geological topologies with high tectonic stress, like standing on a fault line, they can use the immense pressure of the Earth to generate intense dielectric suppression fields.
Oh, wow.
It's a deeply poetic concept. The organism uses the geology of the Earth itself to bury high-entropy radiation signatures and trauma archives deep within the crystalline memory banks of their bones.
Okay, so what does this all mean for you, the person listening to this right now? Your DNA is a live, conductive wire scanning for errors. Your bones are piezoelectric engines capable of generating 80+ volts of electricity. And the tiny microtubule structures in your brain are trapping actual UV photons to literally hold on to your memories.
Exactly.
You aren't just a biological machine living in the universe. You are actively decoding its waves. You are a rendering engine.
That is the ultimate synthesis. The historical, classical view of biological life as a simple, deterministic chemical engine is dead.
It's dead.
We are a massively parallel quantum coherent architecture. We are constantly mutating, adapting, and synchronizing with the invisible forces of the cosmos using atomic spin, biophotonics, and the Earth's own physical force.
It completely changes how you view yourself when you look in the mirror. I mean, you aren't just meat and bone.
You're really not. And this raises one final profound concept from these deep-level theories that I think ties everything together perfectly.
What's that?
The incompressible residue.
The incompressible residue. What is that?
It's the idea that no matter how perfectly we map the quantum wave dynamics, the biophotons, the radical pairs, the Posner molecules.
Right, all the hardware.
Yeah, all of it. There exists a fundamental incompressible residue in your experience.
Okay.
It is a primitive thisness of your first-person experience that simply cannot be reduced to computation, information, or wave dynamics, no matter how advanced our understanding of the substrate gets.
So to put that in a sci-fi context, if we ever invent perfect brain uploading in the future, it might only copy the filtered neural patterns.
Right.
Like, it might copy the hard drive, but it could never capture that fundamental, irreducible residue of what it actually feels like to be you. You are, at your quantum core, impossible to copy.
Precisely. The hardware can be mapped, but the raw experience of the renderer remains entirely uniquely yours.
Man, what an incredible place to leave it. Thank you so much for joining us on this deep dive. If you're listening, step outside today, take a deep breath, and remember, you are manually tuning your magnetic resonance when you do, and just feel the quantum reality you are actively rendering right now. See you next time.